So Ted, take it away.
All right, Randy, can you hear me? Can you see my PowerPoint?
Yes, screen looks great and you sound fine.
Okay, great. All right, well, thank you everyone for coming on. What I'm going to talk about today is about a recommendation that the TWiP team put out in December on tornado warning, polygonology, and communication best practices. And then I'll get into a couple other quick things at the end of this. So I don't know if everyone or anyone who has had a chance to look at that memo, it would be a good thing to do that. And again, we'll go through that here right now. And we start out in that recommendation talking about discussing strategies ahead of time. And I think you would do this in your own office, certainly, but not just about what type of storm you might expect today, but how are we actually going to draw polygons, you know, and what are the factors that might affect that during today's event. So obviously you want to look at the NSE data. I mean, you all do that anyway. And then what do you anticipate? And then during the event, what do you observe as far as storm modes go, the behavior and the motion of storms, and what is the potential today for short track versus long track tornadoes and how that might affect how you send out your warnings. Supercells, are they going to be splitting and cyclic if you're going to get those? And how does this affect mesocyclone evolution? And QLCS mesovortices, how do you think that's going to evolve using the 3 ingredients method? And how's that going to dictate how you draw your warnings based on that? And then as we know, things can change during the convective environment. Boundary interactions can certainly have a big effect on what ends up happening versus what we anticipate going into the event. So we'll start here with warning duration. This is a big one here. You know, back in late 2007, storm-based warnings came out, and as we know, the idea there is to warn only for the areas that are actually threatened, regardless of the underlying boundaries and county lines, and also to shorten the default duration warning from 45 to 30 minutes. And the idea there was to reduce time that an area was subject to a warning. Now that has had potential consequences, and here lists several of those. You can get warning overlap. You can get multiple warnings for the same area. Therefore, if it's a tornado warning, your communities may be setting off sirens multiple times. Metropolitan areas have a better chance of being split between 2 warnings if you have shorter warnings. With more warnings, you can have potentially lower lead time and a higher false alarm rate. With more warnings as well, you can increase your office workload, not just in issuing them, but in follow-up severe weather statements as well. And this does have the potential to increase confusion or misperceptions by our partners. Now, some national service assessments have come out and said that there is this thing called warning fatigue, that the public can get this false alarm perception if there are too many warnings issued, and that's regardless if the warning is actually verified or not. So we discussed this amongst the TWiP, and we recommend a 45-minute default tornado warning duration. Now that may hit you and be like, what? But the idea here is that's not a mandate, that's just a recommendation. Certainly if the storm is close to the edge of your CWA, you're going to issue a shorter warning. And if you perceive that the tornado threat from a particular storm is shorter in duration, then obviously go with a shorter length of warning. Either way, update the information, the warnings frequently in SPSs. All right, next slide here. Let's look at the size and shape of our warnings here. There's an example on the right. I'm going to kind of go through the bullets, and then we'll look at this example. The idea here is our default warnings that come out, I think as many know, are just too big. And first of all, if you're late on a warning and you got to get a tornado warning out, you know there's already on the ground and you don't have a warning out, I don't care, just get the warning out. Don't fiddle around with making your box better in terms of what you're warning for and what you're not warning for. But in general, the polygon is too large, so we want to reduce that polygon. We want to minimize, again, warning overlap, multiple warnings for the same area, and locations that are clearly not threatened. So what is a good idea is when you issue a polygon warning to have the cities displayed so you actually know what you are warning for and what you are not warning for. So things to do here. You take the downstream edge of your polygon, you pull it back before the arrowhead, not just to the arrowhead. Again, the idea here is the arrowhead is supposed to be where the storm is going to be at the expiration time of that warning. based on the storm motion that you have calculated in WarnGen. So if you pull it back before the arrowhead, that gives a better chance for that storm being out of that polygon by its expiration time, therefore reducing the amount of overlap and multiple warnings for the same area. Certainly downstream, if you're just clipping a small part of a county that you can get in the next warning, then pull those back so you don't overwarn an area that you will have to again rewarn because the storm never gets there in the first place in the first warning. One thing that's a big thing that I don't think people consider as much is not just the upstream and downstream edges, but the lateral edges here. Pull those lateral edges in that example on the right, the northern and southern lines of your polygon, pull them in. And we'll talk about that a little bit more in just a minute. On the upstream end, all right, often it goes back behind, at least for a supercell, it goes back behind where the threat actually is. Remember, when you're issuing a warning, that storm continues to move as you get that warning out. And often we can tend to warn for areas that are the threat has already passed, and certainly that's not what we want to do, especially in terms of a tornado warning. So pull those vortices, those vertices in as much as you can there. If you have high confidence, don't wait till the storm gets to the downstream part of your polygon to issue a new one. If you have confidence that the tornado threat continues, get that out as soon as you can. And obviously we know that, especially for tornado warnings, we do not want to keep warnings in effect when the threat has passed. So be very proactive in trying to cancel those as quickly as you can. And last bullet there, just no elliptical or circular polygons. So going to that example again on the right, on the left column there, you see the default warning on reflectivity and SRM. Now I kind of call this a clean supercell because reflectivity gradients are pretty tight, but you have some other supercells that's a little messier. And you can see that that warning is going to way overwarn for the threats. Now, if you have, especially if you have an underlying severe thunderstorm warning, now when you do a tornado warning, you don't need to worry about, say, RFD winds or large hail. You can just really hone in on where the actual tornado threat is. But even if this is your first warning, you're going straight to a tornado warning for the supercell. All right, if you look at the right column now, you see the adjusted ones. You can see that on the downstream end, that warning is pulled back for the arrowhead. You can see on the upstream end that those vertices are pulled in right to where the severe weather threat and tornado threat is. And notice the lateral extent of it is pulled in from the north and from the south. Now remember, in a supercell, the largest hail falls out near the updraft, downdraft interface in the weak echo region. It does not usually fall out in the front flank downdraft. Now granted, you could get one or two here and there, but if you're issuing a tornado warning, let's think of what we're doing here. And let's just really warn for that tornado threat or the most highest susceptible part of the storm in terms of impacts and effect on people. So we can pull that in. We don't have to warn for the whole storm. That's warn for the severe and tornadic part of the storm when we issue our tornado warnings. Now, in SVSs, okay, you got your warning out. What are you going to do from here? So that schematic here on the top one is assume that's your initial tornado warning. The red dot is your mesocyclone or the location, your rotational couplet, what have you. And then the green arrow is the line that the WarnGen gives you. So this is the warning you've issued. Note that it's a little wider on the southern edge to account for maybe a little bit of right turning. Now, when you issue your SVS, what are you going to do? Too often I see this occur, and obviously you pull the warning up to where the current tornado or rotational couplet is now on the back end. Well, obviously that's good, but we leave the sides too wide. Remember, as the initial fanning of the warning is because there's uncertainty on where the storm will be by the time it gets to the end of the warning, okay? But as the storm moves through the warning, that uncertainty decreases continuously because now it's obvious in that option one that tornado is not going to hit the southern or the northern part at the end of that that polygon. So we want to really be cognizant and pulling in those lateral sides to really just continue to warn to where the tornado threat will be in the remaining part of that warning. Again, for some of you, this is preaching to the choir, but I've seen this happen, and I just want folks to be cognizant of this when we update these warnings. Let's go to pathcasts. Obviously, we issue pathcasts, I think, most of the time. There's always talk about whether we should just have a list of cities or whether we should provide time of arrival information. National service assessments, including the Table Rock derecho event, the duck boat accident. In that one, it was determined that if we do not provide adequate information to our partners, our customers, that they will try to manually determine when these storms will get there, and they will make decisions based on their own interpretation, which may, or in this case, may not be correct. So we really want to be careful and make sure we provide information and update it frequently, which I'll talk about more here in a second. So to do this, two things. First, maintain a really good, thorough, and accurate list of cities, towns, and other locations in your AWIPS data, in AWIPS, so that your warnings can access those cities. And when you make your, and second, when you make your polygon smaller, as we discussed, you are going to get a better set of cities, and it will pick out ones that are really actually under the threat versus others that may be more on the periphery and have less threat of the worst weather. Okay, let's talk about the catastrophic tag now. We had discussions with Central Region ISD, who will come out with guidance very shortly on this. But the idea here is, in the very rare event that you say, have you issued a tornado warning, all right, and you're upgrading that warning to a tornado emergency, in other words, issuing the catastrophic tag, do not do that in an SVS. Instead, issue a new tornado warning, all right? Don't worry about as much as the existing tornado warning you had, but concentrate now on that tornado emergency. Issue in a new tornado warning, not in an upgrade in an SVS from the original tornado warning. This ensures that more customers, more of our partners get to tornado warning faster, and therefore can take critical steps to keep themselves safe in what is a potentially life-threatening situation here. And again, ISD will come out with more information shortly on that. Warning teams. Some of you in your offices probably do use this. We find this to be a very good thing to do in discussions on the TWIP. This specifically is two-person warning teams at adjacent workstations most often. Anytime there's a tangible tornado threat. Now, of course, this does depend on staffing, and with the current state of things with COVID, I mean, this is all, it's difficult to do some of this, but normally two-person warning teams is a very important thing. It has a lot of benefits. You can do, and each team will do their own warning statements and mesoanalysis in their covered or their assigned coverage area. So the benefits include here, it increases data valuation. There's a ton of data in the NSC reports and all the AWIPS data, including dual poll and how that plays into the decision process. Two people can process that better, much better than one. Effective communications is unbelievably important. At Louisville, we've done some WEST simulations doing two-person warning teams where we have one person on the WEST and another person on a PC next to it with the GR2 data that's synced up to the WEST radar data. Now, when we facilitate that, obviously we're concerned about the science and what people are doing and decisions they're making, but we really want to see what the communications are, the dynamic between the two people. All right, and how they're talking to each other, getting a consensus opinion, different opinions, varied opinions, okay, to make the most intelligent decisions possible. And remember, the warnings that come out from our office is not from a single person, it's from our office. So the more effective communications we have in evaluating the data that's there, the better. And the warning team puts you in a better situation to achieve that. Remember that you do need to be open-minded and receptive to different opinions, because not everyone's going to agree on the same data, making the same decision. It also has benefits of reducing warning fatigue. All right, you get to switch roles, but you're both aware of what's happening because you're looking at the same area. It reduces human bias, which I'll talk about here in a little bit. And then it also provides great mentoring opportunities. If you have someone paired with a more experienced person, that can have a side benefit as well. All right, comms with our partners, not now internal communication, but communication with our partners and messaging. It goes without saying that we want to do that as frequently as we can. A lot of our partners in the EM community and the media say that NWS chat is one of the most important ways that they get their real-time information during an event. So let's look at these two bullets below it. Let's start with the SVSs. So obviously, those are what we want to continue to do. If it becomes the choice between an SVS of an existing warning, new warning, there's no doubt you want to put out the new warning, but we want to update the information, especially for tornado warnings, with new information. If you can cancel part of a county like we talked about, or if your pathcast information is dated, or you have new impacts, new intel from what's going on, pass that along in these SVSs, and also pass along in chat with quick blurbs in chat. We should be sending out stuff every few minutes there, every couple minutes. It depends on the situation. But what was your basis for your warning? Is your path of the tornado or the rotational couplet, has it changed from what you were initially thinking? And even if it hasn't, state that. What's the impact that's going on here? If you see a TDS, explain that, or that you have a radar confirmation basically of a tornado. And even if you're not warning for a storm, all right, convey that information. People might think, media or somebody might think, why are you not warning for that storm? We'll state that. These are the reasons. Maybe it's slightly elevated or what have you, or if it's approaching a populated area, state the reasons for what you're doing. Remember though, the last bullet, no pre-release warning information. If you're going to state something about a warning coming out, then that warning needs to be coming out basically at the same time. All right, and the last slide in this section here is we have a good partnership with WDTD. In their current RAC course, they have 5 modules which talk about polygonology and warn gen, issuing warnings, IBW, and continuing, canceling, and expiring. I talked to at the BOECA workshop in the beginning of March. A few of us on the TWIP team were there. Talked to a couple of WDTD people that were there. So these are still good modules, and we recommend if you need a little bit of refresher, then go through some of these modules here to find out that information. Okay, so what I want to do right now is just switch gears for a little bit and talk about the human factors. Now, this is based on what we did at least a couple years ago, and when we did a survey of everyone, and what's the current state of the decision process at local offices. And we're really interested in the local office culture and the human bias. Obviously, on the TWIP, our job is to really enhance the scientific understanding of proper conceptual models for supercells and QLCSs and recommended procedures of how to issue warnings for them. Make that decision objective. But obviously, with people making these decisions, and the people are so important to this process, but we have to recognize that every person brings a little bit different talents to the table, and inherently that can cause inconsistent IDSS if we're not careful about that. So first and foremost, at every office, these are things to think about now as we are now entering into the new convective season. First of all, build that foundation, that rock foundation in your office. If it's not already there, which I'm sure it probably is in most instances, promote a cohesive, inclusive culture in your office in general and in the warning, in warning operations. Each person is valued. They all bring talents to the table in the total IDSS that we provide, and they should also be personally accountable. Once you have that, now each person should be looking at themselves. All right, whether you're at your office on shift or you're at home teleworking now, that's a good time to do this. Look at your own personal filters. All right, these have effects on the warning decisions. As I said, it can cause inconsistency. So be introspective. Look in the mirror. Recognize, reduce your own personal biases. And not only that, but understand others and learn the tendency of others. So again, we want to make these decisions more objective. And also understand when you are at work issuing warnings, all right, fatigue becomes a factor, mental and physical fatigue and stress, especially these days with everything that's going on. Stress can get the best of us. So we want to make sure we continue with high levels of SA. So warning teams help here. So you can switch out. So know your limitations. Don't try to be a maverick. So now we can put that together. When you understand your own tendencies, let's try to put it together with that of the entire office. So these days you can do, you can have a survey that gets put out, and everyone can do that, even if you're on telework. And then through, say, Google Hangouts or another way, you can actually talk amongst yourselves, the people in the office, and discuss the range of knowledge, the personalities in your office concerning, for warning services. What's each person's risk tolerance? Do you actually issue warnings more quickly? Or are you one who's more conservative and holds back a little bit? What are your biases? Get a better understanding. Again, learn the tendencies of others. Come up with a plan here. Develop a plan for your office so you know this and can recognize it and be aware of this during actual events. And share this, if you're willing to, with other offices and even with the TWiP team, because we want to take a deeper dive into this whole human aspect of the tornado warning decision process, because that has at least as much importance as the sound science. And again, we want to make the decision more objective and less subjective as much as possible. And then finally, after the event, be personally accountable and go back and look at your tornado warning decisions. If you have made one, do a candid self-assessment. Be very candid with yourself. Be very fair. Take a long, cold, hard look at yourself. Did you do a good job? Great. If you didn't, then go back and look at this and find out what you didn't do right, or if you missed something, and then be honest about that, learn from it, and then move forward. And then the office itself can do a local AAR, after action report, to look at the assessment that you provided. It doesn't have to be some gigantic dissertation. Just look at a few scientific things that were most important and a few human-based elements that were most important, and go from there. All right, 2 more quick slides here. Let's switch to the deliverables. This just shows everything that we put out on the TWiP team so far. We put out 23 training videos to date. They're all on YouTube. That includes our QLCS curriculum. That includes our Supercell curriculum so far, and it includes a couple Landspout videos that are out there. The Radar Features Catalog is something that provides extra examples of many different signatures besides the examples that are in the videos. We have 21 so far. We'll be adding to that as we go on. 10 memos of recommendation, which one of them I just talked about, obviously. We have different color curves that are out there, and you all gave us input to that, of what the best color curves are to recognize features that are important to the decision process. And they're not only for AWIPs, but they're also for GR2, and there's some alternate color curves that are available as well, besides the primary ones that are recommended. We have some quick reference guides for mesoanalysis from the NSC awareness team. That was disseminated through the TWiP. We have the digital cursor readout where you can put mesoscale model data over top of radar, and it helps with mesoanalysis. Just talked about the human bias, and we have other information that's on our website as well that's related to everything we're trying to do. And then finally, future efforts. Where are we going? Well, we certainly want to finish our QLCS videos. That's still going to take some time with everything going on, but we still have a number of them still to go. We have a couple of new supercell videos coming out on the survey, the storm relative velocity enhancement, and how that relates to tornado genesis and supercells. And we want to continue to update the conceptual model for supercells. A couple other videos that we're planning at some point here is one on spectrum width and its utility, and azimuthal shear. As I mentioned just a minute ago, we do want to take a deeper dive in the human element. And if you do notice things in your office, or you do come up with some commonalities, share those if you're willing to, because that really helps us to really look at how this whole element affects the underlying decisions and ultimately the IDSS that we give to our partners and customers. We'll continue to expand our Radar Features Catalog, as we mentioned, more WES, or actually start with some WES simulations actually through the TWiP. We wanted to get that going to FY20, but probably now it'll be delayed more to 21. AWES procedures and perspectives or data usage strategies are important. Do those, try to get that going some more. If you have some good ones, send those up to us so we can start assessing some of those more than we already have. We started doing that some already. We can act if needed. If you're doing a local post-mortem, you want a little bit of advice, I mean, we're here. We'll be glad to take a look at it and offer you some unbiased opinions if possible. It's totally up to you. I mentioned we have partnership with WDTD, and we also with a number of other folks and university people and SMEs, so we'll continue with that. We also threw around the idea of the radar boot camps, and we'll see how that goes. That's our initial thinking with that. And I think that would be really cool thing, kind of similar to like the mesoscale analysis boot camps. So we'll see how that goes moving forward. And we do know that things we're doing in TWiP is not just, it's for Central Region, but certainly it has organic expansion to other parts of the Weather Service. And that's a good thing. That's a really good thing, because ultimately, as a whole, the Weather Service, we are responsible for keeping people aware and safe. And so certainly these ideas, they're picked up elsewhere. That's awesome. So that's really all I have. Here are the websites that we have. We have parallel or mirrored sites on Google Drive and on VLab. And our videos are on our YouTube channel. And thanks to Jeff Mannion in Central Region SSD, these are also on and linked in the CLC so that you can track the information and the completions by people in your offices. So with that, I'm done. Thanks, Randy, and I'll take questions.
Awesome. Thanks, Ted, so much for excellent presentation. If you have